guys, welcome back to my channel. If this is your first time with us, please don't forget to hit that like and subscribe button for more fun physics content. If you've been with me for a while, you know that I make physics videos for fun, right? Right? I am in no way, shape, or form being forced to do this for fear of a failing grade. Anyway, let's get started. Today we will be investigating electric force and interactions between charged particles. When objects come into contact with other objects, this can be anything from tearing, to rubbing, to even just touching. Electrons can be transmitted between those two objects. This creates one object with a net positive charge and one object with a net negative charge. The goal of the lab was to determine the amount of charge transferred to a piece of tape as it interacted with different objects. I started out by tearing off about 8 inches of Scotch tape and sticking it to my desk. Then, I tore off another piece of around the same length and placed it on top of the other piece of tape with a sticky side down. When I pulled the top piece of tape off, it became charged. I stuck it vertically to my desk and then brought a neutrally charged object, in this case a pen, close to the tape. You can see that the tape moves towards the pen when it gets a certain distance away from it. In order for this to work, I had to handle the tape as little as possible. My hands were neutrally charged, so every time I touched that piece of tape, some of the charge on the tape would have transferred to my hands. Next, I charged another piece of tape using the same method and moved it within proximity of the first tape. Unlike the tape and the pen, which attracted one another, the two tapes repel each other. This was because the two tapes were the same charge, and like charges repel each other. This information is all fine and dandy, but the real question is, were the tapes positively or negatively charged? To find this out, I rubbed a pen through my hair and then placed it near the tape. When plastic is rubbed on an object like hair, it develops a net negative charge. Thus, when placing the negatively charged pen by the tape, if the tape was also negative, it would repel, versus if the tape was positive, it would attract. When I tested this, I found that the tape was positively charged. I used this new finding to help me determine the numerical charge of the tape. I rotated my two-tape experiment sideways and kept one stationary while moving the other under it. When I moved one piece of tape under the other, the like charges repelled and the stationary tape rose against the force of gravity. I tracked how much the tape moved and used that distance, 3 centimeters, to calculate the charge of the tape. I started out by making a free body diagram of the forces applied. These were the force of gravity in the negative y direction and the electric force in the positive y direction. Since the tape was unmoving, the system is in equilibrium, and thus the momentum of the system is 0 and the net force applied is 0. This means the force of gravity should equal the electric force. The force of gravity is calculated as the mass of the object, in this case 0.16 grams, times the acceleration of gravity, or 9.81 meters per second squared. This gives a force of gravity of 1.57 newtons. I set the force of gravity equal to the electric force. Notice here that the final equation looks a little funky. This is because we assume the charge of both tapes are exactly the same, since they are the same material and charged in the exact same fashion. Due to this, we can simplify the equation down after plugging in the values 0.03 meters for d and 9 times 10 to the 9th for 1 over 4 pi epsilon naught. I got a value of 3.98 times 10 to the negative 7th coulombs for the magnitude of the charge of the tape. When you divide this by the charge of an electron, 1.6 times 10 to the negative 19th, you can find that there are approximately 2.47 times 10 to the 12th excess electrons on the tape. To better visualize this relationship, I created a model in Python to show what would happen when the two tapes came into contact. This model also calculated the electric field, the force of the electric field, and the force of gravity, as well as the charge of the tape. This model represents the ideal scenario for the electric force. It negates air resistance and treats the tapes as if they were point charges. The ideal electric force was determined to be 7.84 times 10 to the negative 4th newtons. The electric field was 8.3 times 10 to the 4th, and the magnitude of the charge of the tape was 9.4 times 10 to the negative 9. An interesting thing to think about when it comes to charges is what would happen if the roles of protons and electrons were switched. What if protons had a negative charge and electrons had a positive charge? As far as interactions went, no one would be able to tell a difference. But at the atomic level, the roles would be switched. Instead of negative charges passing between objects, positive charges would then be passed between objects. That's about all I have for you today, folks. Hope you enjoyed learning some interesting things about physics. Tune in next time for more fun physics videos.